Once you search for the NACA 0012 airfoil on airfoiltools.com, you're going to select this first option and we're going to send it to airfoil plotter. So click here on this send to airfoil plotter, and what we need is this chord measurement. So we're going to go back to our model and calculate how much chord we need based on the blueprint. All right, so I can now hide these 3 surfaces at first because I need the transparent, like so. So these 3 surfaces, I'm going to make them 75% transparent so I can see through what we are doing here. And now we're going to go back to the product mode by double clicking on this product. Insert a new part to this product 1. Click now to use the same origin, and then you're going to press Alt Enter and change the graphic properties name. So here I can say it's the tail stabilizers. So write stabilizers and then the part number tail. And now double click on the part. And we are now in the GSD workbench. So kindly select Generative Shape Design workbench. So we need this chord at the bottom right here. And the first thing we're going to do is to add an axis system here that we can use. So you can select this edge of subdivision 2. Select point, circle, sphere or ellipse center. And select this edge. You're going to get that point. Let's go back to the right view so you can see it right at the middle of this ellipse. And then select OK. We're going to insert an axis system right on that point. But now if you go to the top view, you can see that the middle section of this stabilizers is aft of this section. So you can actually translate an axis system. Select on translation. Select the axis system 1. Direction is the y-axis. And then you're going to drag it up to the middle of that section. So you can see this is the middle of both the vertical and the horizontal stabilizers. Like so. And select OK. So first I'm going to hide this initial axis system. So we are left with this one, and then go back to the right view. So to be able to determine the chord, we can just first draw these guides. So you're going to select the ZX axis of this translate 1. So you can see we're on translate 1, and then sketch. So to make the guides, it's very simple. Just click on line. Start at the either at this point or at the top. I'm going to start at the top. So you start from this point and then make sure it lies on that guide from the blueprint, and also it touches the x-axis. Then click, and then you're going to exit the workbench. So that is the first guide. Then select the ZX plane once more and sketch. I'm actually going to go to the right view so I can see this line. Maybe I can select this point, project it. This is not necessary, you can just place but because it's not visible here, project it as a construction element. Then create a line, which is also a construction element from this point up to this end point, so that you can see where the line is starting from, like that. Then exit construction back to the normal elements. And now you can see the line is highlighted, so you can see where you're starting from and you're also ending at the x-axis. Click on that so you can adjust this line right there. Just make sure this coincident constraint is still active, and then exit. So those are the top guides. We can create the bottom guides now. So sketch the ZX plane once again. And I want the points to coincide, so I'm going to select the point, select construction element, and then project it as a construction element. And then I can now start a line from that point. This is now a standard element up to this edge, like that. Exit. Sketch once again the ZX plane. Then I'm going to select this point, project it as a construction element, and then click on line from this point. This is now a standard element up to about that point. Exit the workbench. So those are our guides. And now you can tell the chord length by just measuring the distance between this point and this point. And in this case, it is 346.748. All right. So this is going to be our chord. But now one thing to keep in mind is whether or not your airfoil is complete. You know, we said there are those that has an open end and those that don't have an open end. In this case, the NACA 0012 has an open end. So we're going to need to join something at the end. So instead of just adding this entire point something in length, we're going to first plot the chord as 346. Then we're going to add a curve at the end to join it, which is 0.748 in millimeters. I hope that makes sense. If it doesn't, you're going to understand it as we do it. So this is 346. So remember to save your work. So now this is the tail part, and just save. Click on yes. So we're going to now our airfoil plotter, and the chord is 346. Then plot and save the CSV file of coordinates, which we're going to open. So now we have the X and Y coordinates, which is exactly what we're going to use. We're going to plot it at the origin first. We don't need to complicate it. So we have X is equals to this, Y is equals to this, and then Z is going to be 0. And then we're going to highlight these 3 coordinates. Up to that point. Then we're going to open the GSD point spline loft from Excel file. Just delete everything in the middle, then cut. I'm going to paste it here first. Then I'm going to get those coordinates, copy, paste them here as values, then cut this section and just paste it at the end. Okay. Now, one thing you need to note is that you cannot plot this airfoil coordinates in product mode. Right now we are in product mode. In fact, if you try to run the macros, they're going to tell you that this object is not supported. So what you're going to do is to open this part independently or in a new window. So tail object, open in new window. So you have to be in part design workbench. You have to be in part design workbench. Then we're going to go to the right view. But remember, we are plotting first right here at the origin. So now you can go back to this file, select view, macros, select main, select 2 for points and splines, and select OK. And you can see we've plotted our aerofoil right here on the X and Y plane. Now what I'm going to do is to just select everything, and we're going to use symmetry using this plane because we need it to face this direction, and then hide or show the initial element and select OK. So this geometry from Excel, I can label it is Alt Enter and just feature properties, and we're going to name this the NACA 0012 airfoil. Now we need, of course, to move this from here to here. And what I'm going to do is to zoom in on this. Zoom completely in until I get the first point, this point, and insert an axis system at that point. So you're going to select this point, select OK. Then now you can go to where you want to place it at this point and also insert axis system. So the origin is that point. So now we can do an axis to axis transfer. And you do just that by selecting the symmetry. So you have everything here on symmetry. Go to axis transfer. Then the reference is from this axis system and the target is this axis system. Make sure you've selected the right axis system, then hide the initial element and click on OK. Now, if you go to the top view and zoom in, you're going to notice that we have an open section. As I mentioned before, that's an open section. So we're going to close this. So instead of using connect curve like we've used later, we need this to be an exact length. So what we're going to do is use a spline, and then this is going to be our first point, which is going to be tangent to this curve. Our second point, we can go to the right view. Let's zoom in. Our second point is going to be where we want the edge to be, which is at that point. And then the third point is going to be this point, which is also tangent to this curve in that direction. So make sure that the directions are matching. This one goes outwards. If you select the first point, the arrow is facing outward. If you do it like this, you can see we have a cusp there. And then the third point, the tangency is facing the curve. Then you're going to select OK. And then you can now join this and this spline. Preview to make sure it's connected and select OK. So now we are working with a join. You can hide that and just leave the curve. Join one. Remember to save your work. Now we can create multi-section surfaces using join one, and then the guide sections are this one and this one. Preview. That's the first section. And then the second section, the bottom one, select join one. And then for the guides, you're going to select this and this. Preview, select OK. You can change the color to whichever one is more visible. So we've got that. You can save. And you can close the part workbench. So when you come back to this one, you can see we have got our sections. So our sections are on the side, and we're gonna need to put 2 columns to support it to the main body, which is the same case as the original one. And now we can hide these sketches. Like so. We can also hide this first axis system and this point. So we can, even when we are creating the horizontal stabilizers, we can work with this axis system if we need to create more because it aligns with where this stabilizer is. So now let's go to the horizontal sections. So we can use this boundary right here to create our horizontal section. But first we need to go to the top view and check the width and the position of this vertical stabilizer if it's at the side. So it still looks like we need to move it a little bit, and we can do that by checking the axis that we moved to the side. I think that was translate 1. So translate 1, we can add the distance. Say up to that point. No, that was too much. And then perhaps we can increase the width of our sections. So we can use affinity for that. Select affinity, and then the elements are going to be these 2 multi-sections. So this surface and this surface. Go back to the top view. So we need to increase affinity in the Y direction. So in the Y, I can maybe try 1.2. Preview. Nope. First I have to select the origin. So the origin, I'm going to select this axis system so that we have even even scaling in both sides. So 1.2, 1.3. I think that will do it. 1.3, let me see, 1.4. Okay, we leave it at 1.4 in the Y direction. And then select OK. We needed to hide the previous, so we are still using this geometrical set. I think we need to move our elements to a new geometrical set. So from where we have join one, that can remain, but the sections, the surfaces, we need to move them to a new geometrical set. So we're going to insert a new geometrical set. Hold on, it seems there is something that is selected. Deselect everything, insert a new geometrical set, and the name is going to be the stabilizers surfaces. And the father is going to be the tail, then select OK. So now we can select the surfaces and then change geometrical set to this, select OK, and then define this in work object. So now the surfaces that we are creating are going to this geometrical set. We can now close this NACA 0012 point and splines. So about that last affinity, we are going to hide the initial element and select OK. And put it back to the original color. So now that's how it looks like. So we had the chord, now we have matched the width. And now we can go to the horizontal one. So first and foremost, when we did the multi-section surfaces, this one was relimited using a flat plane right here. So instead of the surface starting from here to here, it was kind of cut off at this point. So what we can do is to create this line from this point up to here, then extrude and split. Let's do that. Just select the boundary, create a boundary here, a complete boundary, select OK, and then extrapolate this boundary. And this is the affinity one, is the section that we are extrapolating. And then just raise it so that it's just above that point. Then select OK. So now we have a new surface, which is extrapole 1. And what we can do is we're going to sketch this plane. And we're just going to create, I'm going to have to hide this. We're going to create a line. We can project this as a construction element. Select OK, so that we have this point. We're going to create a line from that point. This is now a standard element up to this place, this position where we want our surface to end, like so. I can also extend this point, this line, like that. Then exit. You can now hide this boundary and you can show extrapolate 1. And now you can split extrapolate 1 using the sketch. Oh, my bad. We cannot split using a line. We have to extrude this. We have to extrude this line to form a surface. The direction. So sketch 5, the direction is going to be the Y component. And we need mirrored extent. And there we have it. And now we can split extrapolate 1 using this extrude 1. Other side, select OK, and hide this. And now we have that slanted profile that we wanted. You can hide the line. We have the slanted profile that we wanted. Now you can select, so this is split 1. Now we can select this boundary, and it's the one that we're going to use to create our profile. Create a boundary, select OK. We're going to translate it upwards. Translate in the Z component. Sorry, the element is this boundary. Then this is the Z component. We need it at the center of this horizontal stabilizer. Select OK. And we need a point in the middle because we need to create affinity in the length and also the width. So you can see it's quite long. And if you go to the top profile, yeah, so we need to increase this length and also the width if need be. But first we can rotate. So we can hide this boundary, create an extremum point in the X component, minimum side, and insert an axis system at this point. Select OK. Now for the rotation, you have to note that the middle line to this airfoil does not necessarily lie on the X axis. So you have to create a line, and therefore we're going to create another extremum point still on the X component and create a line here for rotation. So when you select rotate, translate to the axis, you're going to right click and say create line from point to point. Let's lock that. And this is point 1 and this is point 2. Select OK. And the angle is 90 degrees. So if we go to the side view, you should have this new profile. You can now hide the initial element. I didn't hide that. Hide initial element. Select OK. So now we have this new profile, and we're going to apply affinity both in this X component and also in the Z component to match our blueprint. So you're going to select affinity, and this is our element. But now the origin, we cannot use this origin. If we use this origin, everything is going to scale up to this side. but we need much of the scaling to go to this side. So we need our point to be, say, about just aft this point a little bit. So what we're going to do is, for the origin, we are going to create a point. That point is going to lie on this plane, on the ZX plane, or you can say, you can create a plane right here and say create plane through planar curve. I think this is the one, through planar curve, and select this is the curve. Yes, so you have a point, a plane which is through these two curves. Select OK. So we're creating a point on this plane, and the reference point here is going to be this point. Then hold on, let's edit that, edit point 1, whatever. The horizontal direction is going to be, it's the one we are going to add value to. The vertical direction is going to be 0. Let's preview that. And I'm going to add 55 as the value. Preview. Select OK. So we have a point aft here. Now the X component, this is 1.7. Okay, that's 1.7. And the Z component, I've put 1.5. I think that also is going to work. So we just need our profile to join with this profile a little bit here, but the ends doesn't matter. The ends can be free as long as it's joining right here. So maybe 1.6 in the Z component. Preview. 1.6. Preview. Yes, so now it's joining at this point. And then I also think this point, I'm going to move it where towards this side a little bit more. So edit point 113. And instead of negative 55, we can try negative 60. So we're moving it more towards this side. No, actually we needed to move it to this side. My bad. Let's try 50. Let's try 50. Negative 50. And then preview. Let's try 1.8. So that it's close to this end more. I still think we should move this point a little bit towards that side. It's extruding more. Let's try negative 45. Doesn't even seem to be making an adjustment, but I know it's moving towards this side. Okay, negative 40. Okay, we can work with that. So 1.8 in the X component, 1.6 in the Z component, and select OK. Actually, we can hide this initial element. Select OK. We can now hide this extremum point and extremum 2 as well. In fact, we can hide this axis system as well, because now we need an axis system here and an axis system here to create the guides. So once again, extremum point in the X component, select OK. Extremum point in the X component, minimum direction, select OK. Now insert an axis system. to this extremum point and insert another axis system to this extremum point and select OK. Let's go to the top view. We can start with this profile. So select this XY plane and sketch. I need to hide this profile. Okay, and then select this extremum 4 and project it as a construction element. Go back to standard element, select a line from that point. It's actually the middle. You don't need to project it because you already have the origin. And then bring it just after the line a little bit, like that. Exit. And now sketch this one. So the reason why we are sketching using two different ones, because they are not lying on the same plane. This is kind of rotated downwards. Then sketch. I'll go back to the top view. Select line from the center or the origin and just a little after that point. Remember, when we are creating the multi-section surfaces, it's going to relimit them using one plane, so it doesn't really matter much. Then exit. So now we can create the multi-section surface. Multi-section surface. This is affinity 3. And these are our two guides. And create OK. So that's our section. And then I don't know if these two axis systems actually lie on the same it seems like they lie on the same X component. I would hope so. So we're going to mirror this. If it doesn't, you can just create a main plane through this curve and use that to mirror. So we're going to select symmetry, multi-section surface 3, and use any of the ZX plane to mirror. And to be able to know if they are actually lying on the same side, you can try to join. If you see any green line along this section, then it means it's not completely closed. So preview. As I said, if you see this green section, then there is a gap right there. There is a gap right there. So instead of using symmetry using that plane, what we're going to do is to create a plane. We're going to create a plane, and this plane is going to be through planar curve, and the curve is going to be affinity 3. Preview, then select OK. And now let's try to join once again. Select join. And now, as you can see, we no longer have a gap. They are both closed. And you can now select OK. So we have this join 2 looking like that. And we can hide affinity 3. We can also hide these two axis systems. And these two sketches. Okay, so we've got that. Next is going to be this vertical profile. So we can go to the side view. and this is at each end. So once again, you're going to create a point, a plane through planar curve, and the planar curve is going to be this end section. Select OK, and then you're going to sketch that plane. And we're going to create this profile, so we can hide that right there. Create a line from this point to that point, another line from this point to that point. I actually need these two lines to be horizontal, so this one is still going to be horizontal. Like so. Then you can use a spline to create this curve. Like so. All right. Exit. So we've got that section. Okay, we can fill. Select fill. Then that's a closed surface. Preview. Select OK. If you want to add some thickness to it, you can either extrude this and fill the curve as well. So you can select the sketch, select extrude. It's going to be this number 2 is visual. The first one can be 20 millimeters or 10. 20 is a bit thick, or 10 millimeters. Select OK. Create a boundary at this section. Select OK. Select that boundary and fill. So now you have extrude, control, fill, and this fill. You can join that, a closed surface, and this join tree is going to be our new surface. Hide all curves. You can also hide this sketch and this plane. So you've got that new surface. Which you can now select symmetry, this surface, and then the reference is going to be the same plane that we used to create this symmetry. I don't know if we can get it here, this plane too, and then select OK. Let's see the side profile. Yeah, so far so good. But I can see, let me hide this. This surface is still not touching this. It's in, oh, there was another, hold on. I showed the wrong surface. Let's hide this. We had an extra pole and then a split. We had an extra pole and then a split. Yes, so that's the right surface that we're supposed to be having. And it's just a little bit connected, but not all the way. So keep in mind, we have not yet closed that top surface and this top surface. You don't have to close it if you're going to use to convert it to a solid, because it's going to close automatically. But for the sake of surfaces, we can just close that. So we can select the top boundary here. I think we already created that boundary before we did rotation. We had translate to, hold on, no. We had a boundary here. Yes, that was the boundary and you can feel it. Select OK. You can hide the boundary now. And just to be sure that's the correct one, you can try to join this surface and that fill. Preview. Okay, so first I'm going to cancel it because I need to fill this surface as well. So I'm going to create a boundary here. The reason why we create a boundary, if you select an edge, for example, at the case where we had an aerofoil and we added a curve, it's going to leave that end part, but a boundary is going to cover everything. And then we're going to fill this boundary. Select OK. You can hide the boundary curve. And you have that new fill surface there and at the top. So there's that profile down there. So there's a profile. Let me hide this. It's not showing here, but we have like a pitot. We have like a pitot tube going down. So we can create a sketch. And then from surfaces, we can sweep a round profile. So I think what I'm going to do, I'm going to sketch this. Let me go back to the side view. And then using profile, create a pitot here, like that. Create a corner. Exit. Insert an axis system at this point and sketch the ZY plane. Sketch. Okay. And then we're going to create a circle like that. Then do a sweep using that circle, and then the guide curve is going to be that profile. Then select OK. We're going to split this sweep surface. No, we want to split the sweep surface. Sweep 1 using fill 4. The other side, select OK, and then you're going to create a fill using sketch 10, and then you're going to join that fill and that split. Select OK. We can hide the sketches now. Hide the sketch, hide the sketch. You can also hide the axis system. We're also going to split this fill at the bottom using this join. Select OK. Now we can join the entire surfaces from top to bottom. So select join, start with join 4, this fill surface, this affinity 2, this split 1, and that fill at the top. Let me hide this. And this fill section, and we should have a closed surface. Preview and select OK. So now we have join 5 is a single surface, and we can show the other join. We can also create a closed surface here by, what is this? This join 3. Let me hide this first. So select this edge, create a boundary and fill that boundary. Select OK and hide the boundary. Repeat for the other side. Hide the symmetry, create a boundary, then fill the boundary, hide the curve, and now we can join. We can join this, and this fill. Preview, select OK. Then we can now show the symmetry and the join. So there we have it. That's our sections. All that is remaining now is to bridge the gap between the two surfaces, and that's really simple. All we have to do is select this ZX plane. Remember, this one is the one that is aligning with these two surfaces. Sketch, and we're going to create a profile, this profile. Just zoom in here about this point, just along the x-axis, and like so. Exit. I'm going to hide the gallery first. So then you're just going to extrude and make the limits to be this surface and this surface. So when you select extrude, this profile, because it's at the middle, the limit is going to be up to element. Select this surface, so it's up to that surface. And then the second element is also going to be up to element. Select this surface. But now you have to check, like it's selecting this side, so you're going to reverse the direction, and now it's going to be from this surface to this surface. Like if you hide this, you can see it's just from this surface to this surface. Okay, so then select OK. Can hide that, and then you can use this new extrude 3 to split these two surfaces. So you're going to split, remove this, you're going to split this joint and this surface too using extrude 3. I hope that is going to work. And actually surface 2, no, I don't need to split surface 2. We're going to replace this with the split version of it. We had the tail. So we're going to split the tail, okay? And you can show the tail so that you see which side is being split. Preview. Yes, select OK. So now these surfaces are now joined, but we are going to leave them as individual surfaces. The only one that I'm going to join is this extrude surface. I'm going to join this split 4 with extrude 3, so that the gap is right at this point. And that is because I want to be able to apply different materials if I'm going to export my model to say Keyshot or something. So now I can name this split, so because I need to be able to identify them. So this join, Alt Enter, is going to be our vertical stabilizer. Caps on, it's going to be our vertical stabilizer. That way I can be able to identify it when I'm going through the surfaces. And then from this multi-split, this Alt Enter is going to be our tail section. We can now apply materials. We can now show our first initial surfaces now. We have the fuselage. We have, oops, hold on. I need to double click on this part. Hide the subdivision surfaces. And I'm going to show the fuselage and the main rotor housing. Then double click on this part. And I'm going to apply material. The same material to the tail and to the vertical stabilizer. Then I'm going to apply maybe a different, we can apply a different material to this or the same. It doesn't. Whatever suits you, you can try to create. That's too dark. Don't know. Let's try this one. Again, too dark. Or at this moment, we can just leave it at the same color. Because we're still going, if you're going to render our object, then we are going to add more materials. Hide this axis system. Tools, hide all planes. Right. Okay, so this is what we've got so far. And now we can create the main rotor as well as this tail rotor, and finally the stand. Then from there, I can show you how to cut out the windows and such using a mesh. I know when we did the DA50RG aircraft, we used freestyle 3D curves and then we projected. This time you're going to use a different method, and that way you can learn different ways of achieving the same goal. Hopefully this is going to be much easier than the original one. All right, so I'll catch you in the next episode.